In the previous class, we are discussing about the compounds of phosphorus and we have discussed about the phosphine. Now we can discuss about the other compound of phosphorus like phosphorus trichloride and that is the pentachlorides. So let us check that how that phosphorus trichloride is and its pentachloride is. You know that phosphine has sp3 hybridization because of the presence of the lone pair on the phosphorus, but it is sp3 hybridization, the bond angle, we know that what it is. So we used to say that. Now we can discuss about the PCl3, that is phosphorus trichlorides. So other compounds we can write is the phosphorus trichloride is. So phosphorus trichlorides, we can say that. In trichloride, we used to write that the phosphorus trichloride, that is the PCl5 is the PCl3, the trichloride is, we used to say that. Now we can first write the preparation methods. We know that the preparation will be that the phosphorus is directly treated with chlorine. If it is treated with chlorine, we'll get that PCl3 is. So let us write that. How we can write that phosphorus, the reaction is. So what we say that is the preparation methods is the first preparation methods. The preparation method we can write is that is we can say first one that we can say that is when white phosphorus, that is P4, obviously if I am writing a discrete molecule, it is a P4 molecule, that is white phosphorus is, when it is treated with Cl2, then it is getting converted into PCl3, but it should be that it should be in a limited, that is Cl2. So I am going to write that it is 4 PCl3, so for that I require that it is 6 Cl2. So I will get that PCl3 can be prepared directly by reaction with chlorine, and that is how we are able to write that. So the phosphorus exists in form of two halides. One is the trihalides, other is the pentahalide. So we are going to discuss what the trihalide is. In trihalides, we will write that how that the preparation is. Other preparation method I can write that is, another preparation method is when reaction with sulfuryl chloride, we used to say that SOCl2, the reaction of sulfuryl chloride with the white phosphorus is. So we'll write that how the reaction is, we'll write that. So when white phosphorus is treated with the sulfuryl chloride, the sulfuryl chloride is, that is SOCl2. This is sulfuryl chloride. So this sulfuryl chloride is, that is sulfuryl chloride, I'm going to write that. Chloride. When it reacts with P4, it forms that PCl3 plus, we'll write that it is SO2, we get that the sulfuryl chloride converts into SO2 plus the third product which is formed is S2Cl2. So that is how we are able to write that the product of the reaction is, I require that, so I'll write this as 8Cl because I require the Cl there also. So then SO2 will write that 8, so I'll write that it is 4 SO2, then I'll get that the twice of this is formed. So this is how I got the reaction, that is. This is sulfur monochlorides. It exists. Monochromide, monochloride, they exist. So we used to say that in this case we get that phosphorus trichloride, the SO2 gas, and the S2Cl2 is formed in the reaction. Sulfur monochloride, that is called. So that is formed in the reaction. So this is how we are able to prepare that PCl3 also. So these are the two methods for the preparation of PCl3. We can write the properties of PCl3. So if we write that properties, what is the properties of PCl3? So in properties we can say that it is a colorless, that is oily liquid. So it is a colorless oily liquid, that is colorless oily liquids, we used to say that. So this PCl3 is a colorless oily liquid, and we know that the PCl3 when reacts with water, so that is we can write that reaction with water, I can say that. So reaction with water I can write like this. So PCl3, I'll write that when reacts with water, that is it is going to be getting converted into, when it reacts with water it will form that this is plus 3 oxidation state. So I'll write that it will form H3PO3, that is also a plus 3 oxidation state, plus I'll get that HCl. So that is how I can write that, how we are going to get that right, the product is. So I'll get the thrice of HCl, then I require that thrice of H2O. So that is how we are able to write the reaction of PCl3 with water is. It forms phosphorous acid. So this is the phosphorous acid is. So phosphorus acid is formed by the reaction, that is when it gets hydrolyzed. That is how we can write that reaction with water is of PCl3. Then we can write that the reaction of PCl3 with water, we have written that it is like this. Now I wanted to discuss that the reaction of CH3COH, C2H5OH, etc. Because we know that to convert the OH into Cl, we use PCl3. If we are having either it is an acid or an alcohol, then in that case, in acid and alcohol, when the acid and alcohols are treated with that is PCl3, then we get the product like this. So we used to write like that we have already discussed in the organic chemistry, you know that, or you will study in the organic chemistry that what are the reactions of PCl3 with acid and alcohol. Not only PCl3, it gives the same reaction by PCl5 as well as with SOCl2, sulfur, that is sulfuryl chloride. So this is I'm sorry, it is thionyl chloride. Sorry, that is because sulfuryl chloride is SO2Cl2, but this is the thionyl chloride. So that is the thionyl chloride and the sulfuryl chloride is SO2Cl2. This is thionyl chloride. Sulfuryl chloride is used for the preparation of PCl5. The thionyl chloride is used for the preparation of PCl3. Because if it is a sulfuryl chloride, then we should write that it is a PCl5, not PCl3. So sulfuryl chloride is used for the preparation of PCl5, whereas the thionyl chloride is used for the preparation of PCl3. So this is thionyl chloride. So here I am writing that if you are using that PCl3, the same reaction will be there. PCl5, the same reaction will be there. Sulfuryl chloride, that same reaction will be there. Or thionyl chloride, the same reaction will be there. In the organic chemistry, we used to discuss this. So that's why I have written that in this case, we will get the reaction like this. So no matter it is like that, you can write that. If it is like that alcohol, I'm going to write that the product of the reaction will be like this. So that is what I'm telling you. So it can be from the alcohol, from acid, it doesn't matter. Next I can write is the third compound is phosphorus pentachloride. So now I can write that phosphorus pentachloride. The phosphorus pentachloride, that is PCl5, we used to say that. Now we can write the direct preparation method as from the white phosphoruses. So I can write the preparation methods. So the preparation methods we can write is that is. First we can write that when the white phosphorus reacts with, this is a white phosphorus, then it reacts with the Cl2, that is, write that Cl2, then we are going to write that PCl5. Plus, we'll write, so we get that PCl5, but you have to just check that, what is the quantity of Cl2 we required is. So I require in this case is the huge amount of Cl2, 20 moles of Cl2, the chlorine is required in that. But in that case, it is the limited quantity of Cl2 is required. So we get that PCl5 and we get that the phosphorus pentachloride with the 5 white phosphorus, which is reactive and it will react like this. Now we can say that the other method for the preparation is, as I have told you, that this is thionyl chloride. Now I'm going to use the sulfuryl chloride. So when phosphorus is P4, the white phosphorus is treated with that is sulfuryl chloride, SO2Cl2. SO2Cl2 is a sulfuryl chloride. You'll get that is, in that case we are going to write that the reaction is PCl5 plus SO2 is formed. So we'll get that PCl5 plus SO2 is the only product. There is no sulfur monochloride which is formed with the reaction. So that's the difference. So we used to say that when it reacts, we require that it should be the 4 PCl5 because P4 we are using, and this will be that is Cl2, so I require 10, so we'll get that 10 SO2 is formed in the reaction. So that is how we are able to prepare that PCl5 by reaction with, this is sulfuryl chloride. This is sulfuryl chloride. So when P4 is treated with this, we are going to reiterate the reaction like this, that is PCl5, the pentachlorides are formed. So pentachloride, that is PCl5 phosphorus pentachloride is formed. Now we can write the properties of that. If we talk about the properties of this, we are able to write like this, that is how it looks like. It is a yellowish white powder and hydrolyzed in moisture. So I can write that it is a yellowish white powder and hydrolyzed in moisture. We can write that it is moist air. So it gets hydrolyzed in the moisture, and the hydrolysis product is, let us write that what is the hydrolysis product of this is PCl5. When reacts with water, it gets converted into, that is twice of HCl plus, we'll write that POCl3, that is phosphorite, that is trichlorophosphine is formed in the reaction. This is trichlorophosphine. What we get is, that is what we call as trichlorophosphine is. So this is trichlorophosphine. Trichlorophosphine. Now this trichlorophosphine again it reacts with, this trichlorophosphine again reacts with, that is, we'll say that water to form. So POCl3 also reacts with water to form, that is H3PO4 plus, we'll say that HCl. So H3PO4 plus HCl, we'll write that. So the reaction is like this. That is thrice of H2O. So I get that thrice of HCl. So this is how we get that phosphoric acid. So in this case, we get the product as phosphoric acid. So this phosphoric acid is formed in the reaction in that case. So we get that the phosphoric acid is formed in the reaction. Then we can say that it is, we'll write that PCl5 on decomposition, what it happens and react with, we know that it is, so we'll write that on decomposition. So on decomposition, it gives PCl3 decomposition, we can write that PCl5 decomposed to give, that is PCl3 plus Cl2. It reacts with, we can write that it reacts with, we'll say that it is RCOH and ROH, as we'll say that ROH when treated with PCl5, it gets converted into, that is RCl plus POCl3 plus, so we'll write that HCl is the product of the reaction. So like that, here we have written that ROH will react with this to form the H3PO4. H3PO3 is the side product, what is formed in the reaction. So that is how we can write that the reaction is. Here also the reaction is like this. We can write that with, right? Now, it reacts with finally divided metals. It reacts with finally divided metals. So, it reacts with finally divided metals. So, metals like we used to say that the silver and the tin. So, when silver reacts with, that is, silver reacts with PCl5, it gets converted into AgCl. Plus, we then write that PCl3 is formed in the reaction. So, I'll write this as like this. AgCl, what I got. And if tin is treated with PCl5, then it forms that SnCl2 plus PCl3 is formed in the reaction. So, I'll write that it is twice. So that I'm able to write that it is, that is, you can say like this, that is SnCl2 is formed in the reaction. So, that is how we are able to write the reaction. That is, tin will be reacted like this. And SnCl2 further react with this to form SnCl4. So we can directly write that, doesn't matter, you can write that SnCl4 like this, you can write like this. That is how the product of the reaction is with metals like silver and tin is. So you can write like that, the reaction with the silver and tin metals are. Now we used to say that another property is in gaseous state. That is, we can write that in gaseous state, it exists as gaseous state, or you can write that gaseous or liquid state. And liquid state it exists as, we'll write that PCl5 with pyramidal, that is trigonal bipyramidal structure with sp3 hybridization. dehybridization, and the trigonal bipyramidal structure. Trigonal bipyramidal structure. Pyramidal structure, we used to write that. So it exists like this. But in solid state. But in solid state, it exists as. But in solid state, it exists as. We'll say that PCl4 that is positive and PCl6 that is negative. So solid state exists as like this and conducts electricity. So conducts electricity in molten state. Conducts electricity in molten state. So in molten state, that was the reason that it conducts the electricity. So it is like that for the PCl5. And also we can write that one more thing. That is, we can write that in solid state, that is phosphorus, PBr5 exists as, we'll say that is PBr4 that is positive and Br negative. It is existing like this. So about that PBr5 also, we know that how it exists in the solid state. Whereas in gaseous state, it exists as gaseous or liquid state, it will exist as PBr5. So that is how we are able to write that. That is in gaseous state and the solid state, how they are going to exist as. Now we can discuss about the oxyacids of phosphorus is. So if I write about that, next we can write is the oxo acids of phosphorus. So if I discuss about the oxo acids of phosphorus, so we'll write that some of the oxo acids of phosphorus. So I'm going to write that, that is the fourth one, we can write that the oxo acids of phosphorus. Oxo acids of phosphorus is phosphorus, we'll write that. The oxo acids of phosphorus, we can say that. The oxo acids of phosphorus, there are many phosphorus acids which exist. We say that phosphoric acid, phosphorous acid and hypophosphorous acid. So let us check what are those are. So we'll say that, suppose I say that it is H3PO4, that is first we are going to write that phosphoric acid. So the phosphoric acid is, we used to say that phosphoric acid, that is H3PO4. That is the phosphoric acid is. So how we get the phosphoric acid, we can say that is on a hydrolysis of P4O10. So it will get converted into, that is, we can say that P4O10, so I can write that P4O10 when gets hydrolyzed, H2O, it will get converted into H3PO4. And we are going to write that, it is like this. So we'll get that 6, that is required the water molecules. So we're going to write that is, we'll balance that like this. So write that 6 oxygen is required because 10 is there, it is 14. So we can write like this. So we can write that the 12 hydrogens, yes, it is. So it is like that, we can write that, right? Next method for the preparation, we can say that, we can write that, these are preparation methods, what I'm writing. Preparations of this. So next method of preparation, we can say that is, we can write that by disproportionation. We can write here, it doesn't matter. Disproportionation of, we used to say that if I'm having H3PO3, then it gets disproportionate on heating, then converted into the PH3, that is a phosphine, and it will get converted into H3PO4, we'll write like that. So that can be converted like this. So we'll say that in disproportionation reaction, this is +5, so n factor is from +3 to +5, so n factor is 2. I'll write this as twice. And here it is +5 to -3, so it is 6, so I'll write that it is 6. The total phosphorus is 8, I can write like this. This is the balanced reaction, what we have is. So we can write that the disproportionation of phosphoric acid, this is phosphoric, there is phosphorus acid. So phosphorus acid has been disproportionate. Not only the phosphorus acid, if you write hypophosphorus, then also it will get disproportionate. Next we can write that directly from, we can say that the phosphorite minerals. The phosphorite minerals, that is, we are having calcium phosphate. So Cl3, that is a phosphate, phosphorite mineral. phosphorite mineral, we can say that when it reacts with H2SO4, we get that calcium sulfate. So CaSO4 is the precipitate which is going to be formed, and we get that H3PO4 is formed in the reaction. So like that, we are able to write that trace of calcium sulfate. So I require that it is like this. So that is how we get the reaction is. So these are the method for the preparation of phosphoric acid. This is phosphoric acid. Next we can write is the phosphorus acid, how it can be prepared. The phosphorus acid can be prepared like this. So Oxo Acids, that is H3PO3, that is a phosphorus acid. Acid. Now we can write that how we can prepare the phosphorus acid is. The phosphorus acid can be prepared by the hydrolysis of P2O3. So the preparation methods, we can say that it is the preparation methods, we can write that. One we can write that is the hydrolysis of P2O3. When P2O3 reacts with water, it gets converted into the H3PO3, because this is plus 3 oxidation state, so this will be also plus 3 oxidation state. This is plus 5, so this is also plus 5. In P4O10, because in hydrolysis, the oxidation state of phosphorus doesn't change. So we used to write that it is how we can get the reaction, so that I'll write like this. That is the product what we get. Another method we can write is the hydrolysis of PCl3. The PCl3, when it reacts with H2O, you'll get that is H3PO4. We used to say that H3PO4 plus we can write that it is HCl. So we can write that trace of HCl, what we get is. So that is the product of the reaction. What we get in this is that is the phosphorus acid. So that is how you can write the phosphorus acid is. And next we can write is their preparation of hypophosphorous acid. So H3PO2 is so hypophosphorous acid. So if we talk about that hypophosphorous acid, then I'm going to write like this, that is its preparation. The preparation of hypophosphorous acid is, we know that what we can do is white phosphorus is treated with, that is the preparation method of this, we can say that it is somewhat prepared like this. First the phosphine is prepared. So we can say that when we react the white phosphorus that is treated with barium hydroxide. When it is treated with the barium hydroxide, I am going to write that with water and will get converted into the phosphine, plus we will get that barium hydrogen phosphate. So it will be barium HPO2, H2PO2 whole twice. I have to write this as, so H2PO2 whole twice I have to write like this. So it will be the barium phosphate, that will be the reaction. So I'll get that as, we can write it as like this, that is the barium phosphate. We can say that it is thrice, then this will be thrice, so oxygen will become 6. This will be 6, then this is twice, so we get 8 times of this. That is how we can balance that. Then this phosphine, which is liberated here, and we get that barium, that is dihydrogen phosphorus. So that will react with H2SO4 to get the product of the reaction. So then I will write that, then BaH2PO2 whole twice reacts with H2SO4 to give us that, we'll write that it will give us barium sulfate, that is white PBD, and we get that H3PO2 is formed in the reaction. So the H3PO2 is formed in the reaction. This is that hypophosphorous acid. Hypophosphorous acid is formed. So that is how we are able to write the reactions of these oxyacids. Now we can discuss their structures. What are the structure of that is phosphorus acid structure, and we can write also their preparation. We have seen that how we can prepare these acids of phosphorus is. So as I have told you that we are having that is oxo acids. We can write that this is how we can prepare the oxo acids are. So we'll write that it is so I'm writing that oxo acids and their structures of oxo acids. So the structures of oxo acids is oxo acids. You can write like this. Now I am going to write that is H3PO4 orthophosphoric acid. Phosphoric acid, right? Or you can write that phosphoric acid. Phosphoric acid. Structure will be like this, the P double bond O, and we get that OH like this. One of the OH will be like this. It is having sp3 hybridized. So this is the structure of phosphorus acid is. Next we can write is that is the structure of H3PO3. The structure of H3PO3 is this is called orthophosphorous acid or phosphorus acid. So this is orthophosphorous acid. Ortho means we are using the normal acid we are talking about. It is phosphorus acid or phosphorus acid. Phosphorus acid. So we'll write this as double bond O. I'll get this as H. Then I'm going to write that it is like this. That is, we'll get that OH and one of the OH will be like this. So that is sp3 hybridization. Then I'll write that the hypophosphorous acid. That is H3PO2. So H3PO2, that is the hypophosphorous acid. The hypophosphorous acid will be like this. Hypophosphorous acid. Phosphorus acid. We used to write like this. So P double bond O. I'll write that. One of the hydrogen will be like this. One hydrogen will be like this. And one of that OH group is like this. So that is sp3 hybridized. This is one replaceable hydrogen atom. This is 2. This is 3. Now we can write that another one. We can say that is pyrophosphorous acid. So the pyrophosphorous acid is pyrophosphorous acid. Pyrophosphoric acid, I'm going to write that. So the pyrophosphoric acid means H3PO4. Make it twice, remove one water molecule, and you get that is H4P2O7. That is the structure. That is the formula for pyrophosphoric acid. So pyro is this phosphoric acid. I'll write it as like this. That is, we'll get that P double bond O. I'll get that OH on this. This is OH, and you can write that the structure of this is like this. So this is the structure of pyrophosphoric acid. Now if I write that it is pyrophosphorous acid. So if I write that pyrophosphorous acid, phosphorus acid, I'm going to write that it is like this. That is. So it is H3PO3, make it twice, remove water molecule, you will get that is H4P2O, you got 6, then you will get 5. Then in that case, you're going to write that it is like this. P double bond O, you'll get that OH, you'll get H, then you can write that P double bond O, you'll get OH, that is H and OH. So you'll get like this, these are the structure of pyrophosphorus acid is. So like that you are going to write the structure of these acids. That is how we are going to get the structure of these acids. We know that how we can prepare the acids. 3 of them I have already told you that. You know that how we can prepare these acids are. How we can prepare from the preparation of different acid is. So that is how you can write that the structure of those acids. We get that. It is like this. So next we can write is few more type of acids. We can write that metaphosphoric acid. So we used to write that it is the metaphosphoric acid is like this. So actually what happens when we treat that, when we heat that, now I can write that that is metaphosphoric acid, phosphoric acid. Metaphosphoric acid is HPO3. That is. So metaphosphoric acid is prepared as when this is H3PO4 is heated at low temperature, that is around when it is heated at 100 degrees centigrade, then it gives HPO, will rate that 3. When this is heated at high temperature around 200 degrees centigrade, then we get that it has P2O5. It is like this. So here we have written that it is the metaphosphoric acid. So this is metaphosphoric acid. We can say that. Phosphoric acid, we can write that it exists as a trimer also or it exists as a polymer also. So polymeric and trimeric. So I'll write that the trimeric metaphosphoric acid. So this is trimeric trimeric H PO3. and B, I'll write that it is polymeric, that is HPO3. So polymeric, it will be N times, we can write like this. So that is exist in two structure, that is polymeric, or it will be that is the trimeric. So if you write the trimeric will be like this. You can just write that like this. You just write the 6-membered ring. That's why the trimers are formed. So in that 6-membered ring, now what will happen? There will be one double bond O and one OH. So you can write like this: one double bond O, one OH, and again I can write that one double bond O and one OH. You can see that there will be only 5 bonds of phosphorus, what we have written here. So that is how we can write that is the polymeric. That is how the trimeric is. Now we can write that the polymeric is, in this case, now you open this chain, you'll get a polymer. So you write that P double bond O OH. You write like this, that is P double bond O and OH. You'll get that as P double bond O and OH. So that is how the polymeric is. So the polymeric phosphoric acid will be like this. That is having one OH with all the phosphorus. So this is how we get the polymeric, and this is how we get that is the trimeric ortho, that is metaphosphoric acids. These are the structure of phosphoric acid. We used to say that, and one more we can write that is called the phosphoric acid. That is, we are going to write like this. That is, we can say that the structure as like this. That is H3PO. That is, we can write that it is H4 it is H4P2O6. So H4P2O6, we can write that. The structure of this will be like this: double bond OH I'll have, then I'll write that it is 4 OH. There will be a phosphorus bond in this. So I can write like this, that is the structure of this compound. We can have this. And it is prepared easily by reacting the red phosphorus with alkali. So red phosphorus with alkali, we get that the product of this. It forms this H4P2O6 is formed. Now, if I have to check that what is this acid is, then I'll just write that on addition of water molecule, what I'm going to get is, that is on addition of water molecule, I'll get that H6P2O7. So let us divide into two acids. What is that? So I'll write this as a combination of, that is H3PO4 plus H3PO3. So it is a combination of two acids, that is the phosphoric acid and phosphoric acid and phosphorus acid. So when the phosphoric acid and the phosphorus acid both combine, that is when they react, it gives this. When they remove the water molecule, I got this. So that is how it is prepared. It is a mixture of phosphoric acid and phosphorus acid. When these two mix, we get this from this when the water molecule is removed. Dehydration. So we can write that it is a pyro acid, we can say that. So it is a pyro acid. So it is a pyro acids. That is a pyro acids, we used to say that. So we already know that this is a pyro acids because we are able to write that from that part how we can get the structure of that. So that is how you can write all the structure of phosphoric acid. All are sp3 hybridized. So all are sp3 hybridized, you can check that. So all the phosphorus atom, all the P atom in acids are sp3 hybridized. And if they are in +3 oxidation state, if P atom is in +3 oxidation state, then it goes to disproportionation. Disproportionation in lower and higher oxidation state. Lower and higher oxidation states. Oxidation state, we can write like this. So that is about the information what we required for the trimeric of these phosphoric acids. So this is about the oxyacids of phosphorus and how we can write the structure of phosphorus, how we get that the trimeric phosphoric acid, and we'll get that it is polymeric phosphoric acid. So these are the structure of phosphoric acids, and we know that how they show the disproportionation. The disproportionation is like this. So if I'm having H3PO3 suppose, then or H3PO2, then this will disproportionate to H3PO4 plus we can write that PH3. We know that how to balance that reaction is. So this is in plus 1. We used to say that this is in plus 5. Then this will be 4. So I'll write this as 4. This is minus 3 plus 1. So minus 3 and plus 1 is that is again 4. So I'll write that 4. So I got this is 8. That is balanced. We can write that like this. So that is how the disproportionation reaction is. What we write this acids with pH bond. We know that the acids with pH bond are strong reducing agents. So we can write that. We'll write some informations. So acids with pH bonds act as reducing agents. So I'll say that, therefore I can say that the reducing character is, therefore the reducing character of. So the reducing character we can write that it is, we can say that of H3PO2 will be greater than H3PO3 will be greater than that is H3PO4. That is the reducing character. And also you can write that the acydic strength, or before that we can write that the reducing character of. Suppose I treat this, for example, we can write that I'm having H3PO2. It is good reducing agent. Then this with aqueous solution of AgNO3, it will get react in presence. Obviously, it is an aqueous solution. Then it will act as a reducing agent and it will reduce the silver. So into that is we'll get that is silver mirror PPT plus HNO3. What we get is plus we'll get that H3PO4. So that is gets oxidized. So we used to write that this is a reducing agent. This is an oxidizing agent. We already know that it is a Tollens reagent. And it will react to give the silver mirror PPT. So this is a silver mirror PPT, what we used to say that. Silver mirror PPT. So that is how we can write the reaction and we can balance that is we can say that H3PO2 will be, that is water molecule is twice, 4 times we can write that. Then we can balance that HNO3 and we get that as 4 H3PO4. And we get that 4 times AgNO3 when I write it as. So we get this as 4, this is 4, this is balanced reaction. So this is a reducing agent, it get oxidized from plus 1 oxidation state to plus 5 oxidation state, this get reduced, it is a Tollens reagent, we know that. This is called Tollens reagent. Ammonical silver nitrate that get reduced to give you that silver mirror PPT like that. So that is how we can prove the reducing character of these acids. So this is the reducing character of these acid is. Now we know that their acidic strength is the acidic strength of these acid is H3PO2 is more acidic than H3PO3 is more acidic than H3PO4. So n factors we know that n factors of this is 1, this is 2 and this is 3. That is the n factor, that is replaceable hydrogen atom. That is called the n factor, we know that. So this is about that n factor and about that the phosphorus, the reaction of this with the phosphorus atom is. So this is about the phosphorus, what we required is, about the phosphorus atom we can have is. So that is about the phosphorus, what we required is, and we can discuss about the phosphorus atom is. So this is all about the phosphorus, what we required is. Now we can write that if suppose we are having one question, we can take one question. So we can take one example as like this. Suppose we are talking about that. Suppose I give you one question that is like this: ammonia reacts with O2. With O2 to give a product A in presence of platinum, no doubt. Product A. Now this A will react with suppose O2 to form a brown fumes, to give B, which is a brown fumes. Now this B reacts with, we used to say that again with H2O to form C. Again with reacts with water to form, that is C, nitrogen in lower oxidation state. Nitrogen in lower oxidation state. Lower oxidation state. Right? Then we can write that nitrogen in lower oxidation state as well as D, the nitrogen in higher oxidation state. Nitrogen in higher oxidation state. We used to say that in higher oxidation state. So that is higher oxidation state. I have written that. Now what we can say is the C with the I negative gives E, that is violet vapors. C with the I negative gives that is E. E is a violet vapors. Violet vapors. Obviously it will be of some gas because it is a vapors. Then we used to write that these violet vapors are liberated. So C and both are the oxyacids of nitrogen. Obviously it is given to us that. That is a hint which is given to us. That is C and D are oxyacids of nitrogens. So oxyacids of nitrogen. Now what we have to find out? So find A, B, C, D and E. What is the answer what we have to get from this? So A, B, C, D, E, you have to find out that. Now you can write that. What is that? A, B, C, D is, what is you are going to find out from this? That is what we required is that A, B, C, D, what we have to write is. So we can say that already we know that it is, we're going to write that it is, so we can write that the answer for that in the first case, ammonia reacts with O2 to give NO plus that is H2O. We already know that in the platinum case. There is a preparation of nitric acid. We know that. So if we write that the balanced reaction is like this, we just write that 4 and we get that 5. This is what we get is 6H2 like this. Now the NO which is formed, this is your A. Now NO which is formed will react with O2 to form NO2. This is your B. This NO2 which is formed after oxidation, obviously I'll write that it is like this. Now NO2 which is formed will react with water to get disproportionate. That is NO2, HNO2 plus HNO3 is formed. So this is your C and this is your D in higher oxidation state. This is plus 4, this is plus 3, this is plus 5. So this is a disproportionation reaction. Now what we required is the C. So HNO2 will react with Ki. So HNO2 when react with Ki, it gets converted into, that is iodine is liberated in the reaction. Plus we get that it is that is KOH. We can write that the reaction is like that. So in presence of acid we get that is HNO2 in presence of acid because the medium is acidic. We can say that. So the reaction that we get is the iodine are the violet vapors and we get that NO plus H2O. We can balance this. So the balancing is like this, the twice of this, we can write that directly with I negative and that is H plus sign, we get iodine vapors. The iodine vapors when we get that twice of this and twice of H2O, that is what we get is. So with twice of H plus sign. That is how we get the answer for this. So this is all about what we get in the reaction is, and we know that the E is the violet vapors, that is this, the iodine has violet vapors. So this is about that question size. This is all about that nitrogen family is. So that's all for the nitrogen family. Next class we can discuss about the next chapter. So that is all in this class. Next class we can discuss the other parts. So that's all.